So let's have a look at the collider and how we can get that working. So I'm just going to make a torus. Let's move, oops, torus, move that up. Notice here I've got quite a few BIF objects now. Every time you connect to this and deconnect, it will make new BIF objects, which can be a bit slightly annoying. So just got to find which one it is. It's not that one. It's that one. So we can delete these ones. All that smoke. I'll try not to make too many more of those. Right. So we've got a collider. I'm just going to take this initial speed off. Attributes. I'm just going to add some rotation to it, so I'm just going to do a little expression. Equals frame, not caps, equals frame times, which is the asterisk, times 3. There we go. That looks a bit weird, but it's just because I'm so zoomed out there, it's gone all widescreen and sort of distorted. So that will just play through like that. So let's get rid of this. Actually, I might just make that 4. Just add one of them as well, just for cleanness. Right. So let's get rid of view. Open this up a bit more. Don't need so much of that. Glider, bring it in, select to the collider object, let's just hit play and see what happens. And we can see it's colliding with that. I mean, it's quite, if I stop that, say pause, you can see it's quite wide around it. Let's see if we can get an angle where we can see that better. See, it's quite scooped around there. And the collider has a similar resolution thing going on that we have in the solver. You've got a relative and an absolute. By default, it's relative, so I'd put that to absolute. And might as well just match what we've got on our geo detail size there, 0.08. And obviously, when you make these numbers, you know, lower, more high res, simulations will take longer. We can see now that that's slightly closer to it. It's not so nearly as far away as it was. So we have a few things. We can do an offset, which will slightly push out that collider a bit more. I think you can do that into negative numbers, so we could make it sort of fake a little bit closer with making that into a negative. Inherent velocity will, the rotation of this collider will be inherited by the smoke. It's how much the smoke is moved by this collider. So if I crank that up to 10, say, you might really see it. Let's hit play. You can see the velocities of the spinning torus are already affecting the smoke. It's pulling it along, because even when it's not actually connecting with it, obviously the torus is pulling the air around as it moves around itself, so it's affecting the smoke in that way, like currents and eddies. So we can see that. So let's put that back down to 1. So that's the collider. We obviously got bounciness, resolution modes, absolutely. We've got solid or shell. Shell, again, same with here. Actually, I think we've got a solid or shell. Shell is for when it's like a plane. If it's a closed object like a torus or a sphere, solid's your best bet. And same here. It's the same thing. And we've got bounciness, so how much the fluid will bounce off this, and friction and all that sort of stuff, which is sort of usual stuff we've seen before. So that's the basics of a collider, and obviously you don't have to rely on just having one. You can make tab collider, you can make another one, and connect that to colliders. When they've got these little 3 numbers, means they can have more than one input. So we could add more colliders. You could add also more different source airs coming from different objects and all that sort of stuff. So that's a quick look at the collider.